When we think about moons, the first thing that comes to mind is our moon, the large, silvery companion that has been orbiting Earth for billions of years. But what if I told you that Earth doesn't just have one moon? Occasionally, our planet captures smaller, temporary moons, called mini-moons, that briefly join us in orbit before wandering back into space. These mini-moons are fascinating phenomena, offering a glimpse into the chaotic dance of celestial objects in our solar system. Let's explore how Earth catches these mini-moons, what they are, and why they matter to science. First, let's start with what a mini-moon actually is. Mini-moons are small asteroids or space rocks, typically just a few meters in size, that get temporarily trapped in Earth's gravitational field. Unlike our permanent moon, these objects don't stay with us for billions of years. Instead, they orbit Earth for a few months or years before they escape back into space. Think of them as cosmic hitchhikers, here for a short stay before continuing their journey through the solar system. But how does Earth manage to catch a mini-moon in the first place? To understand this, we need to talk about gravity. Every object in the universe with mass exerts a gravitational pull, and the more massive an object, the stronger its gravity. Earth's gravity extends far into space, creating a gravitational well that influences nearby objects. Normally, small asteroids passing close to Earth zip by without any significant interaction. But every so often, the conditions align just right. Imagine an asteroid traveling through space on a trajectory that brings it near Earth. If the asteroid's speed and angle are within a specific range, Earth's gravity can grab hold of it, pulling it into orbit. This is easier said than done. For an asteroid to become a mini-moon, it needs to enter a delicate balance between Earth's gravity, the asteroid's speed, and the gravitational influence of the Sun and Moon. If it's moving too fast, it will simply slingshot past Earth. If it's moving too slowly, it might get pulled into Earth's atmosphere and burn up as a meteor. Once captured, these mini-moons typically don't have stable orbits. Unlike our moon, whose orbit is relatively predictable, mini-moons are constantly jostled by the gravitational pull of the Sun, the Moon, and even other planets. Their orbits can be highly irregular, looping around Earth in chaotic patterns. Over time, these influences often cause the mini-moon to either escape Earth's gravity and return to an independent orbit around the Sun or plunge into our atmosphere, creating a fiery meteor. One of the most famous mini-moons ever discovered is 2006 RH-120. This tiny asteroid, only a few meters wide, was captured by Earth's gravity in 2006. It orbited Earth for about a year before it escaped back into space in 2007. While it was here, it behaved just like a natural moon, albeit a very small and temporary one. Discoveries like 2006 RH-120 are rare because mini-moons are difficult to spot. Their small size and dim light make them challenging to detect with telescopes. But why should we care about mini-moons? These small celestial visitors are more than just cosmic curiosities, they're valuable to science. Mini-moons offer unique opportunities for studying the origins and compositions of asteroids. Unlike distant asteroids in the main asteroid belt, mini-moons are much closer, making them easier to study. In fact, they could serve as prime candidates for future space missions. Scientists could send robotic spacecraft to study mini-moons up close or even bring samples back to Earth for analysis, providing new insights into the building blocks of our solar system. Mini-moons could also play a role in future space exploration and technology. For instance, they could serve as stepping stones for asteroid mining, a potential industry that aims to extract valuable resources from space rocks. Their close proximity to Earth makes them an ideal testing ground for technologies and techniques that could later be applied to larger, more distant asteroids. But there's still so much we don't know about mini-moons. How often does Earth capture them? How many are out there, waiting to be discovered? Advances in telescope technology and sky survey programs are helping astronomers answer these questions. Projects like the Large Synoptic Survey Telescope, LSST, now known as the Vera C. Rubin Observatory, are expected to improve our ability to detect and study mini-moons, revealing more about these fleeting companions of Earth. Ultimately, mini-moons remind us that our planet exists in a dynamic and ever-changing cosmic environment. While we might think of space as vast and empty, it's teeming with activity. Asteroids, comets, and other celestial objects are constantly moving through the solar system, influenced by the gravitational pulls of planets, moons, and even the sun. Mini-moons are a small but fascinating part of this cosmic dance, offering a window into the processes that have shaped our solar system for billions of years. So, the next time you look up at the night sky and see our familiar moon shining down, remember that it might not be alone. Somewhere out there, a tiny, temporary moon could be orbiting Earth, unseen and unnoticed, before it continues its journey through the stars.